Good day and welcome to today's class. Today's class is a continuation of our previous classes on standard forms. In today's class, we shall be looking at expressing decimal numbers in standard form. Decimal numbers in terms of multiples of 10. At the last class, we looked at whole numbers in standard form, where we looked at powers of 10 and I gave you examples on how to express multiples of 10 in terms of powers of 10. And we did an example as stated on the board where we have 10 raised to the power of 14, meaning 10 multiplying itself 14 times. But we also have, that is if you keep multiplying 10 by itself. But what if you keep dividing 10 by itself? It gets to a point where you go into fractions and lesser fractions. So how do you express such numbers in standard forms? That is what we shall be looking at today. Decimal numbers can be expressed in terms of powers of 10, and in this case, the powers are negative. Unlike the multiples of 10 greater than 10, we have positive powers of 10, as seen in our last class, where we have 100 being expressed as 10 times 10, which is 10 raised to the power of 2, and 1000 is said to be 10 multiplying itself 3 times, which gave us 10 raised to the power of 3. So in today's class, we shall be looking at decimal numbers, which in this case, the power becomes a negative. Negative indicating that it is a fraction. For example, we have 0.1. 0.1 as a fraction can be expressed as 1 divided by 10 because this 1 is occupying the 10th place value, and this can be expressed as 1 divided by 10 raised to the power of 1 because in terms of multiples of 10, at the last class I told you that 10 can be expressed as 10 raised to the power of 1, and if it is a fraction, 1 over 10 raised to the power of 1 can now be expressed as 10 raised to the power of negative 1, indicating that it is a fraction. Also, 0.01 can be expressed as 1 over 100 because the last digit, which is 1, is occupying the 100th place value, and that can be simplified as 1 divided by 10 to the power of 2 or 10 squared because 100 is expressed as 10 squared, which is equal to 10 raised to the power of minus 2. And so on, we have 0.001 is expressed as 1 over 1000, and 1 divided by 1000 is expressed as 1 to the power of 10 raised to the power of 3, which is equal to 10 raised to the power of minus 3. Same thing goes with the next number. 0.001 can be expressed as 1 over 10,000, and 10,000 can be expressed as 10 raised to the power of 4, which is equal to 10 raised to the power of minus 4. We have for 10 raised to the power of minus 5 and 10 raised to the power of minus 6. But what do you observe? While looking at it, you will discover that after the decimal point, there's a relationship between the power of 10 as well as the number of digits after the decimal point. In this case, we have only one digit after the decimal point, and the power of 10 is said to be 10 raised to the power of minus 1. In the second example, after the decimal point, we have 2 digits, and the power of 10 is minus 2. After the third digit, the power of 10 is minus 3, and so on and so forth. So that should inform you that there's a relationship between the number of digits after the decimal point to the power of 10. So if you look at this, you have how many digits after the decimal point? 1, 2, 3, 4, 5, 6, and this is expressed as 10 raised to the power of minus 6. So I said, what do you observe about the numbers of digits after the decimal point and the power of 10 in each of the numbers? We have observed that there's a relationship between them and that they are equal. So I then ask you, how many digits will the number 10 raised to the power of 7 have after the decimal point? Your guess is as good as mine. that it is equal to 7 digits. Now the question goes again. How many zeros will it have between the decimal point and the digit 1? Definitely is going to be 6 digits, because in this case, when the number of digits is 3, we have 2 zeros. When it is 4, we have 3 zeros. So that the number of zeros is always 1 less than the power of 10. So in 10 raised to the power of 7, 10 raised to the power of minus 7 can be said to be 0.1234567. So in this case, we have 6 zeros and 7 digits. Kindly like our videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so, also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You can also share the link with your friends and families so that they can also benefit from our classes. You're also advised to follow us on all social media at Facebook, TikTok, Instagram, YouTube, all at My Lesson Teacher. Let's look at more examples. In example 1, we are asked to express 0 point this in terms of power of 10. So expressing this, I'm not going to rewrite it, but I'll just move straight ahead in giving the answer. This can be said to be, remember what I said at the last example, it is going to be 10 raised to the power of minus the number of digits you have after the decimal point. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is going to be 10 raised to the power of minus 16 as your answer. Let's take more examples. We are asked to express the following in terms of power of 10. And for the decimal numbers, we are going to start from question 6. 0.1. 0.1 can be expressed as 10 to the power of minus 1, because we have one digit after the decimal place. This is equal to 10 raised to the power of minus 1, 2, 3, 4, 5, 6. 10 raised to the power of minus 6. And for number 8, this is equal to 10 raised to the power of minus 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 raised to the power of minus 9. Question 9, this is 10 raised to the power of minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 10 raised to the power of minus 14. While this is equal to 10 raised to the power of minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 10 raised to the power of minus 19. 11 can be expressed in standard form as, this is 90,000, and 90,000 can be said to be 9 times 10,000. For 10,000 is expressed as 10 raised to the power of 4. So 90,000 can be expressed as 9 times 10 to the power 4. 12, this is 4 million. 4 million can be expressed as 4 times a million. And a million is expressed as 10 to the power 1, 2, 3, 4, 5, 6, so that 4 million is expressed as 4 times 10 raised to the power of 6. 13, this can be expressed as 3 times 1 divided by 100, 3 times 1 divided by 100, and this is equal to 3 times 1 over 10 squared, which is equal to 3 times 10 raised to the power of minus 2. Based on what we have done, this is 8 over this. So we have it as 8 times 1 divided by 10 million, which is equal to 8 times 1 divided by 10 to the power 7, which is equal to 8 times 10 to the power minus 7. 15 can be expressed as 10 to the power minus 1, 2, 3, 4, 5, 6, 10 to the power minus 6 times 10 to the power 1, 2, 3, 10 to the power 3. So this is how to express these numbers. That brings us to the end of today's class. In today's class, I have been able to explain to you how to express decimal numbers in standard form. But before we go, I shall leave you with an assignment which you are to do and submit in the comment section. The assignment said you should write the following as fractions. We have 10 raised to the power of minus 2, 10 raised to the power of minus 4, 10 raised to the power of minus 1, 10 raised to the power of minus 9, 0.003, 0.00007, and 0.0009, as well as 0.001. These are 8 questions that I will expect you to do and submit at the comment section. In exercise 1.3, you are to write the following in decimals. So you have 8 of them. Kindly pause and copy out the assignment and then write them. Kindly like our videos as you watch, while I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You can also share the link with your friends and families so that they can also benefit from our classes. Thank you and do have a nice day.